And I want to welcome Ron and Crystal here. There's this great story, and I forget where it's come, where it says, I live in Falston, which is in Maryland, which is in or Harford County, then in Maryland, then in the United States, and then it keeps on going out into the into the universe. Is that from like Our Town, that book? I don't know if y'all know that introduction. Well, that's what I reminded when I was scheduling Ron and Crystal, because they're going to tell where we live, but on a more global space indeed. So we welcome Ron and Crystal. I'm going to spotlight you, and I'm going to ask everybody to go ahead and mute themselves. And we will start with today's presentation. So, Ron and Crystal, welcome to OPAL.
Good morning, everyone.
Morning.
So it's great to see so many faces and see everyone joining in. This is our first time doing a Zoom presentation. So bear with us because technology is great when it works, but sometimes it glitches. So just bear with us as we muddle our way through. So this is my husband, Ron. He is going to be the presenter today. I'm his wife, Crystal. And we've been doing this about 10.
12. It's 12. It's more than 12. We argue about this all the time. We never know. It's been a long time, long enough.
Yeah, so we kind of created Night Wonders. I should say Ron created Night Wonders because he has a passion for all things space. So today you're going to get the presentation where we live, like Chastity introduced it. We start here on Earth and we go out. We end with the universe, and you're going to see how we're actually part of the universe. So some of the things that we do live viewing when the weather permits us to do that, which is not very often.
That's with a telescope.
Yeah, we take a telescope out. We do in-person presentation. And we've done the senior center at Parkville. We've also done the AARP down there in Parkville. We also have a mobile planetarium that we take out. And that's actually how we met Chastity and her daughter. We were in our dome and she came out, brought her daughter out to a festival in Hanover. And Chastity remembered us.
Yeah.
And yeah, Hanover, Pennsylvania.
Yeah, because there's a Merrill.
And just asked us to do this. So to end, I'm going to be monitoring on my phone. So if you have questions, feel free to unmute yourself and ask, or raise your hand. Hopefully I'll see that, and we'll get to you and answer your questions. Otherwise, you can wait until the end. We love interaction. So we hope you enjoy this presentation, and I'm going to turn it over to Ron. I'm going to start sharing our screen here.
One, there we go. And so time and the way we know of Earth and where we live, as soon as we leave the planet, it changes. Our calendars do not work anymore. Time is different out there. And so we'll explain that as we go. Even your weight changes because gravity changes depending on where you're visiting. It's not just weightless. As soon as you visit an object, you become weighted. And so here's a picture of Earth. You'd expect to see like a whole Earth in front of you, something like you'd see on TV or on a movie or at the beginning of a movie, the weather. Here's what happens when you go into space. You may see Earth differently as you're going around it. It may be like this one here is a crescent. Looks sort of like the moon, but you can see that blue color. It could be a half, it could be 3/4. And it will change as you orbit around Earth or as you move further away from Earth. Okay, next slide. I always wanted to know this when I was younger. What does it look like? A satellite left Earth going out into the larger solar system, and it took a picture of us. So this is the real picture of what Earth looks like and what the moon looks like together. And you can see the true distance that the two are separated by. Obviously, the big blue, and that you know what that one is. Notice that both of them are cut in half. So when you see lit objects in our solar system, all of them will be presented differently, either a whole or a crescent or a half, depending on where the sun is from where you're looking when you're looking out of spacecraft. We're going to visit the moon first. 12 men have walked on the moon, and right away your day changes. If you're on the moon, your daylight period is already 14 days here on Earth long. And once you get nighttime, it's 14 days long again. So your day is actually 29 days long. And your weight has changed. I can tell you what regular adults will weigh. When you get up there, you're going to be between 16 and 32 pounds. That's quite a bit lighter. Now, the astronauts we're showing on here were 61 pounds when they were up there. That's because they had extra equipment on top of their regular weight, which usually was around 180 pounds. This is Apollo 15. You can see mountains. You can see we're right next to a crater. They were sampling rocks and some of the dust there. And over here is an example of running on the moon. Those suits were very restrictive. You couldn't move your ankles, your wrists, and bend over very well. When you fell over, most of the time you needed help from your fellow astronaut to get back up because they were just too stiff. But if you wanted to get somewhere fast, you couldn't run like a normal human being. You had to do that bounce. So there he is bouncing probably about 6 feet at a time. This one isn't a complete video. If you saw the complete video, he actually falls over and somebody has to come up and pick him up. Okay. So we're going to visit just 2 of our planets. We have 8 planets in our solar system. Venus is our closest one, not Mars. And it's the second planet. And it is approximately the same size as Earth, maybe just a tad bit smaller. It's filled with clouds. You cannot see the surface of Mars from space or from Earth. So when we look at it through a telescope, you really don't see, you just see a nice bright ball. And that obviously that has a crescent. Sometimes you see it half in different phases. Now the Russians went to Venus while we were going to the moon. They had 18 missions and they were successful at landing eventually. And they found out more than anybody else about what Venus is like. It has the most active volcanoes. There's a picture on your left of what their vehicle looked like, their spacecraft when it landed. And you can see there's volcanoes, lava, craters, but it's a very hostile environment. And here's the picture of the surface. Once that landed, it had very little time to take a picture. It found out that it's 900 degrees anywhere on the planet. Never really gets that much cooler. That's Venera 9, 1975. So you can see they were doing this a while back. Its atmosphere is carbon dioxide, but those clouds are not rain clouds. They're actually made of sulfuric acid that came out of those volcanoes. And as they filled up the atmosphere with more smoke and pressure from underneath, they made the air pressure extremely high. So when you're there, it's like being under our ocean. So it would tend to squash you as soon as you got out of your spacecraft. And it actually did start squashing their spacecraft itself. And the acid actually started eating it away, the metal parts. And so it only lasted for about an hour. So that's how hostile it actually is. We will never be able to bring a human being there. It's the technology to keep you safe. You can't even slightly be exposed to Venus. The other oddity about Venus, and here again, your calendar changes. A day on Venus is longer than its year. And so that'd be quite a messed up calendar. We like to joke that, well, at least if you were born there, every day is a happy birthday. Here's our 4th planet. we have visited Mars the most. We take satellites up there and we take pictures all the time. There's one up there taking pictures as it orbits around Mars. This big giant expanse you see here on the red planet is called Valles Marineris. This is like our Grand Canyon, except this one would expand the whole way across the United States from California to New Jersey, and it would be 5 miles deep. So it's a huge gash on this side. The other inset picture is of Olympus Mounds. There are 4 large volcanoes. This happens to be the largest volcano of any planet that we have out of the 8 in our solar system. It is extinct. It is bigger than Mount Everest. So that's what that looks like from space. And we'll take you down and let you look at the surface, because we've had rovers up there for a couple decades over time. This is an active robot up there, rover, and you can see it took a picture, and it kind of looks like our out west. Rather pleasant. You can see that sky up there is not blue. Most of the time, your sky up there is yellow, pinks, and oranges. That's because of all the dust and sand in the atmosphere. There are very little clouds, so it doesn't rain or snow. And it's impossible really to rain because the average temperature on Mars is 85 degrees below zero. This is one of the things that information and NASA kind of skip over. They want to colonize Mars. But minus 85 degrees below zero is quite cold. That's colder than our Antarctic and Arctic. They have that rover. You can see there's sharp rocks and stuff. It travels 4 feet at a time. It has a drill on it, so it can check out those rocks. And they drill down in, and actually the surface that's red on that red planet is just a 1/4 inch thick. Once they get down there, it turns white like a quarry, like here on our Earth. They put that inside there. There's an oven that heats up that material, and they can tell what Mars is made of. So it just goes around and keeps drilling through rocks and see what else they can find. The top part marks out a laser. It looks like a camera. The actual 2 square boxes below that are the cameras. That laser shoots out a laser beam at some of the larger rocks, so it doesn't even have to go up to them, and then sends a beam back, and it can tell what that rock was made of. So they try to limit how far they have to go, moving at 4 feet at a time. Here's what it looks like in an expanse. This was another one that was down in a crater. That crater is huge. I mean, it could cover one of our counties here in Pennsylvania. And you can see the trail coming up. It's absolutely gorgeous. So this is what an expanse that you would view if you were on Mars. Here again, your weight has changed. So for regular adults, you'd weigh between 38 and 72 pounds. That's still a lot lighter. You get a boost from being here on Earth because the Earth's gravity is stronger, mostly because of the size of the objects we're on. What's the other thing here? Oh, you can't breathe. You're going to have to wear a suit. So being colonized, people going up there, they will never be able to touch the rocks. They will never be able to experience the outdoors on Mars because there is not enough atmosphere to breathe. And even if you could breathe it in, it's made of carbon dioxide, not oxygen. So you would suffocate immediately. And then you freeze all at the same time. Okay, I think that's it on Mars. Oh, one more. Here's the weather. They get dust devils. And so these are little tornado things. And one of the rovers caught a whole herd of them coming up through a valley, which was pretty spectacular. Now, if you were there and you're in your suit, because of the low pressure in the atmosphere, these would go actually right over you and it would barely sway your body. So they're not very dangerous. They just pick up dust. But solid things, they absolutely do nothing to. And they actually invite these to hit some of the rovers because they use solar energy. And there's so much dust up there that becomes inefficient after a while, after the dust lays on top of them. So as one of these sweeps by, they hope it actually goes over the top to blow the dust off of the solar panels and bring the energy back up. so they can survive a little bit longer. There we go. Did I go forward too?
I think it did.
There we go. Went forward too. We're going to go to Saturn. When we show this outdoors, what we call live viewing, it's spectacular. This is always what we call the wow, because people, when they get the first look, if they've never seen it before, just go, wow, I can't believe it. I can see the rings. It has a rich gold orange color. So it always looks beautiful. Now, this has the most moons. We visited Mars, has 2 moons. This one has 274 moons. So we're going to show you what those rings, it's about just short of 1 billion miles out away from Earth. So we're getting a little further away from Earth. So here's the rings. There are trillions of little snowballs in there. You could actually pick some of these up with your hand. Some could be as big as your house. Others could be actually as large as a skyscraper in New York City. These are all moving, spinning, and they are also moving counterclockwise as the whole unit with Saturn, the planet, is moving counterclockwise around Earth. So you got 3 spins going on all at once. And this is what forms the way the rings look in their panels, almost like a tractor in a field was growing corn or something like that. Saturn takes 30 years to go around once. So you can see, again, your calendar has changed. 1 year on Saturn is worth 30 here on Earth. Time moves, is counted differently. Now, Cassini went up there and visited, and it took a lot of those moons and went by them. And they also dared to take it through this ring. And when it went through, it took a picture. That's the inset picture. We think it looks like a mushroom or maybe a tooth or a boxing glove. But that's what the snowballs actually look like. Trillions of them. One of the largest moons it has actually is the only moon in our solar system that has an atmosphere. It's large enough. It's as big as the planet Mercury. It's called Titan. And here's a picture of its approach. You can see there's land underneath you, and that bluer color there means that there's an atmosphere there. They had a probe along with Cassini, went down, went through the atmosphere, and started taking pictures. The one on the upper left is the mountains as it was coming through, and you can see these little like lines on the side of the mountain over there. They are rivers. And so they knew a liquid was falling in this atmosphere on Titan. Then they found the lakes, which is the bottom left-hand picture. And finally, they landed on the right side. And then I have another inset of just how small this probe was. It was only about 2 feet tall and maybe about 4 to 5 feet wide. So it was a very small unit. Took that picture. That was its final picture. They thought they were looking at rocks, but they later, as soon as they analyzed them, it turns out that they're ice. So these are rocks of ice. This moon has liquid, but it's not made of water. All the water there is frozen because the temperature is minus 290 degrees below zero. So everything's frozen. So we have to ask the question, what is the liquid there? Well, most of this planet is made of methane and ethane. That happens to be the chemical makeup of the gasoline that we put in our cars. So I can tell you what this is going to actually smell like when you get there, if you could survive the minus 290 degrees. So, and you also know that your gas will stay liquid all the way down to 290 degrees below zero if that ever happens on Earth. Okay, so that was a surprise to them. They were looking for life, obviously, because they detected oxygen and some of the other materials that would lend itself to life, but it just turned out to be too cold. Oh, where's my thing there? So when we started, we found out about star parties, and this was associated with astronomy groups. So there are astronomy clubs. We joined York here. We joined an astronomy club. And this is one of their favorite things to do is go out and they have telescopes. People gather around and they look through the telescopes at the stars. This picture here is in between July and September, when our nighttime sky is facing towards the middle of our Milky Way galaxy. And so there will be a bright white curtain of clouds in the sky, and that is the center of the Milky Way. What you're actually looking at is a star birth area called a nebula. So if you ever heard the word nebula, that's what they're talking about. This is a star birth area. So all these clouds are actually coming together. The gravity increases in there, the heat increases, and at a certain point, it will catch itself on fire in space. Stars are fireballs. So leftover material becomes planets, moons, asteroids, comets, and all those other things. So you're actually seeing the inner workings of the universe right there, just in our galaxy. This is what the Milky Way looks like. We cannot go out there because it's too far. It's well beyond where a spacecraft can go. You can see that it's a big swirl thing that has arms. Each one of those arms, if you're reading like the Perseus arm or the Scutum Centaurus, Sagittarius arm, these are all constellations. So that's the direction when we look at constellations, is where you're going to find them, on those arms. So that's why they named them that. The red circle in the middle is where we're at. We're halfway between the center of our galaxy and the outside of our galaxy. And that little yellow dot, that's our sun. The red line is most of the stars that we see in our sky. We can't see stars outside that line because they're too far away. So if you think there's a lot of stars out at night, we're not looking at hardly any of the stars just in our own Milky Way galaxy. You can see there the Orion Spur. When we're looking in winter, we're looking away from the middle of the galaxy, so we're looking outward, and that's why we see Orion, one of the constellations that sits out there all winter long. You've heard of space telescopes. The Hubble telescope's been around for decades. That's actually as big as a school bus. It has an 8-foot mirror round in the back, and it circles around Earth every 90 minutes. And they point that out into space to see objects that are way out in our Milky Way. The James Webb is a new one. They wanted to increase the size, so the gold part of that is actually 18 feet across, and this is why they could see much, much further into our universe beyond what is in our Milky Way. And we're going to show you these pictures. So most of the pictures after here are going to be from the telescopes. The pictures before of Saturn and stuff were taken from robotic spacecraft that went out there and took the pictures. And by the way, down there at the bottom, nope, how did I miss it? It's just back. That thing keeps disappearing there.
Yeah, there you go.
Okay, at the bottom, you'll see Voyager 1. I'm just putting that information there to find out how far away. 1977, they launched the Voyager missions. They went through the end of our solar system, and now they're trying to get out into the larger Milky Way galaxy. They're 15.66 billion miles away, which is actually not very far. It's not even a light year. And over there, I have 1 light year. Once the miles in space get too big, they change that to a light year because it's easier for them to actually mark points in distance when you're out that far in space. So one of them is 1 light year is worth 5.8 trillion miles. So our next star would be 4.2 trillion, 0.2 light years away. So you'd have to times that by your 5.8 trillion miles. And so we're somewhere around 24 trillion miles away from our next star. And you can see here that the Milky Way is made with hundreds and hundreds of millions of stars. So yeah, we're not even close to our next star. It's so far away. A spacecraft leaving here would take 70,000 years to get just to our next star at our current rocket speeds. So here's a James Webb picture. It's called the Pillars of Creation, and this is one that's in the center of our Milky Way galaxy. And I thought this had something to do with religion and the pillars of creation, God and everything. But what they actually were talking about is another star birth area. And here it gives you a closer look at those star birth areas. Inside the clouds, you'll notice that the stars are muted. They're not bright and shiny, and you don't see all those nice spires on those big, giant, bright stars to the middle and left of the screen. They're the baby stars. They're not officially stars. They're being stars created right there. And over in the inset on the right side is a radio telescope picture. And this shows you the exact what it looks like as a star is being born. The star is in the middle there, obviously, and then you see rings, darker rings going around it. There's one towards the center. That's going to be a planet. And the two out there are going to be two planets together on the outer edges of that. And so they're not officially a solar system or a star yet, but this is what it looks like when it's being created. So they have the ability to look that fine. And this one would be inside that pillar. I don't even know which one it is, but that's amazing that they can look through all that space into the middle of our Milky Way and pick out one exact star and show you it being formed.
Oh, it is.
Yeah, it's a GIF. So here's an animation of what's going on. So most typically, those clouds will come together. As they come together, they'll heat up. I already explained that. And at a certain temperature, they'll burst into flame, the material that it's made of. So these are molecular compounds out in space in the clouds. It's not like our rain clouds. He's going to have many different materials in. Once they start forming the stars, these clouds will actually dissipate and open space will start to appear. When that happens, all those stars being made by that one clump of clouds will be in the rear back area. You can see this is where we get our star clusters from. These are after the clouds have done their work. They become star clusters, and those stars will keep moving away from each other in space until they become spread out. And in time, we'll even lose that star cluster. It'll just dissipate because of the distances between them. So we'll show you some local examples of star birth areas. And you have to go no further if anybody's familiar with Orion. Orion is a constellation, Orion the Hunter. And we have that on an inset on the right side. He has 3 belt stars. He has a diagonal star, that's the sword. The blue on the bottom is the ankle, that's Rigel. And up on top, up there is Betelgeuse, which is an orange that marks his shoulder. So ancient times, they thought this looked like a hunter. There's actually a dog and a rabbit to go with it, and Taurus the bull all goes with that constellation. I have it circled red, so we're on the left side of that star belt, and that would be on the screen on the left side. And you can see 2 different nebulas. One's called the Flame Nebula. The other one's called the Horsehead Nebula. So there are stars in there and stars behind there, which actually lights those clouds up. The darker parts in the front are actually shadowed from those stars because the clouds are so thick. This is part of that where they're making new stars. And so it appears dark. They think that dark part on the horsehead looks like a horsehead. We actually think it looks like a seahorse. But one of the things we like to do when we present this is invite people to use, and especially children, to use their imagination, see if they can see anything else. Because astronomy actually can be fun. You can make it fun using your imagination. And so we also think that looks like an alligator over a stump down in Louisiana, or perhaps a bull, or a ram sheep, or a floppy-eared rabbit, or perhaps a dog with long ears. And so some of these shapes you can make whatever you want to be. Over in the Flame Nebula, Crystal thinks it looks like a unicorn with the star there. I happen to think it looks like a wolf. You can see his ears, his eye, a stripe going back across this body there, and the nose up front with a tongue hanging out and the jaw open wide with teeth. And so, yeah, you can do whatever you want, and it makes it much, much funner. Here's Orion again. If you're down in the sword, you notice that where that red circle is in the inset, one of those stars looks very, very fat. That's because it's not a star. It's actually another star birth area called the Orion Nebula. These are very close to Earth compared to the rest of the Milky Way. And so this one is so bright that you can use a child's telescope and still be able to see it very well. This is not a picture through them. This is still the Hubble telescope. And you can see that in the center where it's the brightest, you can see more stars in there. Here is the star cluster actually starting to form as that cloud dissipates. Here's another kind of nebula, but this is of a dying star. They call this the butterfly. And you can actually see he has antenna going out the front. And that is supposed to be the North Pole. And that line going through the middle is the North and South Pole. And where the wings come out, that's the equator. A dying star means it's shedding its atmosphere out into space. And so those wings are actually very wide compared to, you can fit several of our solar systems inside those rings. That's how wide that actually is. And there is still a star in the core. So they're making white dwarfs after they get smaller. So if you ever heard that term, that's where they're coming from. I put up in an inset here to tell you where that is in the sky. That is in Scorpius. That's where you can find this. And it just so happens we are moving from spring to summer here, just about in the summer. And Scorpius is one of those constellations that's rising in the eastern sky. And it looks very much like a scorpion when you see it. Some of the constellations you look up in the sky don't really actually look like what they named them. But there's a few that look exactly what they named them. And this is one of them. Here's another dying star. And this one gives you even a better look because you're looking down from the top. That would be like the North Pole. And in the center, there is actually a white dot there. That is the white dwarf. And here's the material going out into space in a radius. And so it makes it look like there's an eye sitting there looking at you, staring back. That star is still making a lot of light. It's shining through the material that the star had already lost. And that's where you get your yellows and your orange color, your rust colors. But it very much looks like an eye with an iris on it. That was in this one is in a fall constellation called Aquarius. You might be familiar with that. There's a 60s song called Aquarius. This is the water boy. And so this is marking ancient times how you had to get before plumbing. You had to go down to a stream with a clay jar and get your water, your daily needs of water, and bring it back. And so you can see the water flowing out. So there's a group of stars that they thought represented that. Another kind of object, kind of one of our favorites to show people. These look like giant snowballs in the sky. This is the Hercules star cluster, and it's actually called a globular cluster. It has hundreds and hundreds of millions of stars, all in a ball. The more you go into the center, the less you can tell the difference between the stars until it all becomes one big, thick, white part. We can show this outside. It is halfway across our galaxy, and it still shows up in a small ground telescope, which is kind of unbelievable that you can actually do that. The Hercules cluster is named for Hercules. That's where you can find it. That's in our actual northeastern sky right now, tonight. That's where it will be. Hercules is you have to go back into Greek mythology. There's many stories in Greek mythology that made him very important. One of the stories was his wrestling a three-headed snake called Hydra, which is usually represented in the sky. And we're even going to push further out to give you a sense of how big our universe actually is. They call this the local group, and you can see Milky Way's on the left, Andromeda's on the right. That's our biggest, closest galaxy to us. And then a little triangle, that's another of the three that are in our local group. But then there's all these little dots around her. What are those little dots? Well, they are actually satellite galaxies. The Milky Way has two of its own. They're called Magellanic Clouds. But you have to go to South America or Australia, and then you can look up in the sky and see these balls of stars about as big as a full moon, visible. It's on our bucket list to get down there and see them with our own eyes or a telescope one of these days. So the argument with cosmologists is they think these are actually small galaxies being born, or something hit the larger galaxy and divided little pieces up, and these are moving away. I happen to think they are being born in our galaxy, because most of them seem to center around the center of the major galaxies and not way out in space by themselves. Here's the Andromeda Galaxy and what it looks like through the Hubble telescope. And remember, light years? Well, this is 2.5 million light years away. See, it becomes impossible when 1 light year is worth trillions of miles to figure out how many miles that is across. But they think this represents our galaxy. If we could see it from outside, we could get that far out. This is what it would look like. You can see those white dots on both sides of it, the top and the bottom. They are the satellite galaxies. So when we look at this through a telescope, I call it a threefer, because you actually get one picture in the telescope gets you 3 different galaxies at a time. If you want to get interested in how many miles this is, you have to go up into numbers, which they call quintillion. And you can see how many zeros are behind that 15, just as an example of just how wild distances get. And we're not even that far out yet. It gets much, much further out. Here's another example getting beyond our local group. It just keeps continuing. This is another, it's called the whirlpool. And you can see those big spiral arms come out. And this one has a companion galaxy, which is also a satellite galaxy, but it's so close and attached. Again, this is the argument. Is that galaxy making that small one, the whirlpool, the companion, or did it break away because something collided with it and it was already there? So they're still arguing. This one can be found in the Big Dipper handle. So the next time you look at the Big Dipper, imagine this is what you could see if you could see right those 3 stars that make the handle. Here's another interesting one called the penguin and the egg. The penguin on the right side, an emperor penguin down in Antarctica. That's what that's supposed to represent. It's a galaxy that's twisted instead of a nice round circular. And in the background, because this one's further away, is the egg. That's another type of galaxy that's much, much further out. And you can find this one in Hydra, the water snake. And this isn't a galaxy. This is actually the Crab Nebula. This represents those things we used to hear called supernovas. And that some stars actually explode into space and then they just spread out. And so this gets larger. This actually happened in 1054 AD, because they have a record from Chinese and some other countries that recorded that this appeared in our sky all of a sudden, brighter, and they could actually see it during the day. But this gives you a good example of how our universe actually works. You notice all those lines look like electric. That's because they are. These are called filaments, and there's so much energy passing through there that you can see those lightning rods coming out from the center. And think of a battery that when you put it in any device, say like a flashlight, you got to get the plus and the minuses correct for it to pass electric from the battery into whatever you're operating. And this is how the universe works. It's always trying to take the extra energy, which would be the plus side, and move it to the minus side. This is universal in all of our universe. This is how it works. It wants to make everything even, but there's always more energy somewhere and less energy the other. And so this is how energy moves through our entire universe. And actually, I'm going to show you later, this is actually how your body works. It's inside of you, electric. So it's more like an electric universe. This happens to be in, oh, now I hit the wrong button. There we go. This happens to be in Taurus the Bull, right in the horns, if you're familiar with the constellation Taurus. And here we're going to show you a larger picture. Astronomers wanted to know, how far can we see out in space? What is the limit to what we can do? So they used the Hubble telescope. And later on, they did use the James Webb telescope. But this one's the picture I like the most. So setting up the picture there again is a picture of the Hubble. And I have a picture of the large moon. They stared at a point, that little tiny square. The only reason I have the moon on there is just so to give you context of just how small that little square is in our nighttime sky. And so they focused that Hubble telescope there for 29 days and took picture after picture after picture, tens of thousands of pictures. And then they put them all on a computer and a program, and they come out with one picture. And here's the picture, which I call the wonder. That is not stars. These are galaxies that were in that little square. As a matter of fact, 5,500 galaxies they counted in that one tiny little pixel square in our sky. So this is what you could see if you could see as far out as you can. There are 3 stars in there from our Milky Way galaxy. If you can spot them, they have spires on them, sort of like the Christmas Bethlehem star. There's one over here. Is another one on the right side, and there's 3 of them. So this is looking out beyond our Milky Way, out into deep space, and getting as many objects as we could in that picture. Now, recently they took the James Webb, went into one of the darker areas here where you can just see just tiny little dots. They are galaxies, and they took another picture. And what they expected to find was the beginning of the universe. They were looking for the Big Bang. Instead of finding the Big Bang, what they found is another picture that resembles the very picture you're looking at now. And so now the argument for cosmologists is the universe finite, or does it go on forever? And from my studies, I happen to go on it goes on forever, because no matter where they look, they keep seeing the same things over and over again, no matter how distant they look out. So right now they think the universe, they're still believing in the finite officially at 13.8 billion years is how far our universe goes out. But there's a whole other side to this. So I showed you the macro universe. There is actually a mini universe that most people do not know. This is a cell in your body. Your body has over 37 trillion different cells that make up your body. You see all the components here. The components aren't really that important, but each one of these components has to be made up. And electric is actually running through each one of these cells. And it's what we call nerves. It's actually, the electric tells your brain that you actually touch something. It sends a signal back electronically to your brain, and it makes you do the things you do. It also digest your food. You eat food, it turns into electricity after it gets broken down chemically, and it moves through your body. So that's how we digest and get our energy that we use to do the things we want to do each day. So all 37 trillion of them have to have a middle and other pieces. You have to go into the atomic level to find this out. Think of the atomic bomb. This is what they were talking about. You might have had this in school. There's a nucleus and there's an electron. And here comes that electric charge again. The nucleus in one atom is positive. The electron is negative. And so the electrons get attracted to the middle and they make an orbit, just like in space. They tried to take a picture of this. That's what's on the right. You can see it's not a very good picture. That's because this object is so small. We don't have an telescope big enough or good enough equipped to get that far down into the mini universe that's in there. And there are trillions of these inside each single cell. So if you're counting with math, yeah, trillions of cells in your body, 37 trillion, and each one of those is made of elements, and each one of those is worth trillions. So the numbers get astronomical. That's why we call it that. So what they found was once they got inside your you can click that off. There we go. When you get inside the atomic, this is subatomic level. You might have heard of that. And they took the proton and found out there's something wiggling inside of each nucleus. This is where we got the word. Where's the? You can stop it on the little icon. I don't know where they are.
Bear with us a second.
While you're doing that, forgive me, I've been in and out with answering phone calls, but did you see that there is a question via chat
No, I
about?
did not see that.
Okay, so again, you talk about stars being born and stars dying. How
Uh-huh.
long is a star's life? The question is.
That's a good question. And it's variable because all of them are different energy sizes. And what they found out is the ones that have the most energy, that burn the hottest and the brightest, burn out very quickly. And they're most of the ones that are dying. Now, red stars, they come in colors. So the blue and white ones die out quick. Yellow ones, they're kind of the average. That's our star. Orange ones last a lot longer. But red ones are the smallest stars, somewhere between our sun and Jupiter. That's the size of them. And they last the longest. Some of them have been measured to last longer than what we think the universe has been there on a whole, which is 13.8 billion years, which doesn't make sense. So you see, cosmologists have quite a few quandaries. They don't know everything. And so those stars, we cannot see many red stars in the sky because they're simply too small, and our eyes really don't receive the color red very well, as opposed to some of the other colors, blue and green. So there you go. Those will last a lot longer, and they're not sure when they actually die. So it's your blue and white ones that tend to do the supernovas, explode, uh, white dwarfs, and all that. That was a great question. So did you get our sound off of this?
Yes, I'm
Good.
off.
Okay. So back to explaining the atomic and subatomic level, they found these little squigglians. They called them quirks. And if you've ever heard of quantum, this is what they're talking about because these things they can't actually take a picture of them. And they're moving so fast, they won't sit still for a picture. But they do create harmonics. They actually hum. And so your body actually hums at a certain frequency. As a matter of fact, the earth hums at its own frequency, and so does every other object in space. And it's all because of that inside that's actually still invisible to us. So they still have a lot of work to do on the universe going in the opposite direction that you never think. Well, yes, that is part of the universe, and this is the basic building blocks of our universe. And I mean, we're beyond light. Light is also humming, but it's all made up. Every little tiny structure in our universe is made up this way. And here's just a picture of it going through our body. These are actually nerve cells in our brain, but nerves, this is what they look like. They come into junction boxes, and then it sends it to different directions. And yeah, this is the wonder of the universe. How does it know which direction to go to? We are amazing creatures. And I just happen to think that our brains are so amazing that computers are they're just not a good example. Our brains work so much better than computers. Um, they're just amazing.
Ron, may I ask a question?
Yes.
Um, I always hear the beautiful sentiment of we are stardust.
Yes, and we are.
What does that mean to you and why?
Well, they think actually the particles keep separating as explosions and the energy transfers, that some of the energy that was used before somewhere else in the universe actually got down to our solar system, actually got down to us. So that's where they mean about the dust. But my example is um, physics. And so the way the structure is of the universe and how it works is the same procedures that are going on in our everyday lives. This is how our body works, it's how our minds work. And so we are just another structure in the universe. And so it moves you from being thinking you're very small in the macro sense of the universe, but also very important because we are the same material. We're actually pieces of the universe.
So Bev made a comment. It's so interesting and helpful to compare the intricacies of the universe to the human body. And that's why Ron did that, because you can see that we are absolutely part of the universe. I don't think a lot of people think of us that way.
Even the life and death system is out there, and it works the same way. Stars are being born, stars die and disappear, and then they move on with their energy, and new stars appear again. And so it's recycling, just like we do.
So, Ron, can I,
Yeah,
and this is Bev here, I'm sorry. Um, I'm interested in knowing your background and what brought you to your interest in this field.
that's another good question. And I really like to tell this story because, you know, you think you have to have special education, or really you just have to have the will to do it. I was a truck driver for 30 years. That was my main business. Getting aged and jumping up and down trucks was getting difficult. And so I decided to change. And that's how I ended up with Night Wonders. But the original story begins with the Apollo mission. When I was 9 years old, that's when we first landed on the moon. And that, if you recall, happened in the middle of summer. Everybody's out in the summer playing, and I was so interested in that mission, I wanted to see it. And they were interrupting with water concrete off and on during the day, and day turned into night, and we didn't see that until 11:30 Eastern Standard Time, beyond my bedtime. So I had to get my mom to actually. I said, I want to see this. I want you to keep me up. Don't let me fall asleep. So here's my mom, instead of putting me, telling me I have to go to bed, she's trying to keep me up, and she did. So I actually saw the original broadcast of them walking their first steps on the moon. And I've been interested, or what I call a space geek, ever since. And it just expanded from there.
Well, thank you. This presentation was really helpful for me. I really don't have any great knowledge. I mean, I have general knowledge. This was very, very interesting. I appreciate it. Thank you.
You're welcome.
Does
And
anyone
we
else
try to
have any
tell the
questions?
story in more of a. Go ahead. I'm sorry.
No, I'm sorry. I was just asking and inviting everyone that to unmute if they have a question for you.
I have a question about distance, I suppose. I don't know, obviously humans cannot conceive of trillions of miles or quintillions of miles or any of that. Somebody came up with that system, I guess, to try and explain it, but there's no way I could understand that. Were those astronomers who tried to come up with a system of telling you how many millions of miles, and then it was light years, and then it was, so all that is just beyond me, but somebody had to think that up in the first place. I don't know if they were mathematicians or if it was the astronomers who had to think of a way to try and explain it to people in a way that we'd understand, which I still don't understand. Thanks.
Actually, both of them, historians, ancient astronomers, as they were looking at stuff, couldn't answer the same question. So they were going to the mathematicians at the time to try to explain that. And so that's where the first systems got set up. they actually couldn't get those right in the beginning, and even now to today, there's variables. So I rarely ever try to pin down. So like somebody says, well, how far away that star is? Well, it's 27.5 light years, but there's actually a give and take of how many light years it actually is, because of the measurements aren't actually exact. So you got to take them with a grain of salt when they tell you how far or how large. Until we actually, the best way is to go out there and go back, and then you figure out exactly how far it is. And since we can't do that, we do know the inner solar system and the outer solar system pretty much exactly how far away they are. That's how I can pretty much tell you that Saturn usually is about 950 million miles away, give or take. Where our orbit is. In winter, we're further away. In summer, we're closer. So that those numbers always change. But after that, stars, only the first 25 stars from Earth are pretty accurate, and then the accuracy starts falling off of how far it is. So
Yeah, thanks. That's kind of helpful. I just feel like it's also beyond me that it's like, you can't really ever tell. It's kind of mysterious as many things I think are these days, even though people like to think they know. Thanks.
Yeah.
I often explain it like if you're know about math, the tens. So you have a number to the 10th power. Well, they do that simply so you don't have to write all those zeros out. Because the numbers get too large. That's just in math as a whole. So they invented light years to do the same thing, because our mileage system didn't work. Even our kilometer system doesn't work. Even temperatures out in space, some of them are so extreme that we use Fahrenheit, and some people use the Celsius, but they actually use Kelvin. They had to invent a whole new system of temperatures just so they could measure the extreme temperatures in space, whether it's absolute zero or it's 50,000 degrees. It's they call them Kelvin now.
So Anita asked a question. So now we no longer think there was a Big Bang?
I don't think there was a Big Bang, but officially, yeah, cosmologists are still on. A lot more are jumping off the bandwagon, mainly because you'd think if it was a Big Bang, it would go out in a radius in space. And so since we think there's a Big Bang, somebody would have figured out with a big telescope and said, yeah, we could see the center of where it exploded. Well, no matter where they look, they cannot find where the Big Bang came from. It's just out there. So that's one big thing for me. I don't think it was a Big Bang, or we would have figured out exactly in space where that was.
Monty wants to know, do you think we are alone?
Oh, gosh, no. Yeah. I mean, we don't see UFOs. I mean, we're not, into the UFO scene and we play with it because it's fun. It's fun for younger crowds. We show them aliens, grays, and stuff from time to time, but we really haven't seen any, and we're looking up all the time. I tell people that, have you seen any, they'll ask me, have you seen any UFOs? I said, well, everything we've seen that we thought was a UFO, we explained. And we're looking up more than other people. Most people only look straight across their eyeballs, and they rarely look down. They even more rarely look up in the sky. And so they're always concentrated on that one zone. So they don't see this stuff, but we're looking up. One of my jokes about me is I tend to look up anytime during the night. It's a wonder I don't run into things, because I'm not watching where I'm going. I could just run into a telephone pole or something because I'm, just goofing off watching stuff in the sky. And we don't really see that. We see rocket launches that get explained, but how many different objects there are, not just planets, because there's moons, there's comets, there's all kinds of stuff out there. There has to be some other form of life, whether that's microbial, where you have to take a microscope and look at it, or if it's insects, just plant life, or humans, or what we technically call UFO green guys who are really smart. Yeah, I think they're all possible. It's a giant sized universe, and it's complicated, and it's wondrous. So I wouldn't count it out.
We get asked that question a lot by school kids. And I tell them that back in 2021, we went to Albuquerque, and the boys wanted to go down to Roswell. So we went to Roswell, New Mexico, and visited the UFO Museum. And I will say, I read everything. I was calling Ron over, read this, check this out. There's very good evidence that there is other life that has visited our planet. Again, we just haven't seen it. Now, Anita asked, after the Big Bang, then what? Basically, she said,
yeah, good question. Cosmologists think that because there was an explosion, once that energy is all used up, there'll be a whole bunch of different worlds all over the place. So the universe will be the same size, except everything will lose its energy and turn cold and die. Wow. I don't like that universe. Yeah, that's really what they think is going to happen. It's just going to burn out.
And then Bev asked, why do you think space exploration is important?
Well, anytime I call us our universe, the more we learn about us, the more we learn about nature, you'd want to know more about space naturally. And so the more you can find out about science, it might be related. Even space could be related to something here on Earth that we haven't figured out yet. So all that knowledge is good. Now, the other part about it, going to Mars and whether we should go to Mars, I think it's a suicide mission. And it's more or less just big guys wanting to plant their flag. And I'm not really interested in that. Just going to Mars just to said, I was the first one. Now, that's pretty much what I want to do.
So Ralph said, Big Bang is a very solid theory. It's true that some of the web data has cosmologists scratching their heads, but it will likely be a tweak to our models rather than discarding what we know.
Yeah, I'm well aware of the where cosmologists are. That's the big frame of the science that they have explained over time. Even the electric universe, which I explained, can be controversial. They don't really think there is electric in space. It's the last thing they usually mention, but it's so obvious. I wonder why they can't plug in electric, because our sun is actually sending us microwave, and that's really what you're getting from the sun. We think it's just light, but there's actually invisible microwave energy. We use it in our microwaves to cook food. It's heating up the earth. It's making grass grow, and then cows eat the grass, and then we eat the cows. And the whole cyclic thing is all going on, all because of an invisible microwave energy, which is part of the electromagnetic spectrum. And yeah, it's electric. All good questions.
I'm loving the discussion.
Well, I want to thank you, Ron and Crystal, for joining us today. And thank you all, our dear OPAL members, for joining us. We hope you enjoyed this kind of programs. As always, I am open for more suggestions because when you have to fill a calendar with good quality program content, I am always open for suggestions. So just drop me an email and would love to hear more. But Ron, thank you. Thank you,
You're
Crystal,
welcome.
for also doing all the tech work as well and adding pieces in that just really made for a comprehensive program. So thank you both, and we appreciate you. Hope everybody else has a great day.
Thank you.
If anybody else wants any other topic, we do so many topics. Hey, the universe is big.
Yeah, absolutely. Well, thank you again. Take care.
You too.
you.
Bye-bye.
Thank you. This was great. Thank you again.